Today we're going to continue working with y equals mx plus b. That's why this is called day 4 of working with the equation of a line. We're going to focus, however, on parallel and perpendicular lines today. And so we've talked about parallel and perpendicular lines before. So let me just remind you how we recognize them. Parallel lines have equal slopes. In other words, if I'm looking at the equation, the two slopes will be the exact same. Perpendicular lines have negative reciprocal slopes. So negative reciprocal slopes means, well, the negative part means that they have opposite signs. So if one slope is positive, the other one will be negative. The reciprocal part means that if I write one of the slopes as a fraction, even if it's not a fraction, I could just put it over 1. If I flip that fraction upside down, that's the reciprocal part. So they should have opposite signs from each other, and they should be flipped fractions compared to each other. All right, so that's stuff that we can use to recognize the equations of parallel and perpendicular lines. Let's do a few examples. Find the equation of a line that is parallel to the x-axis passing through the point -2, 3. All right, so let's visualize this. If this is the x-axis, this is the y-axis. And it's going through the point -2, 3. So remember, -2 on the x-axis is to the left of the y-axis, and 3, that'd be up here. So here's our point, -2, 3. Zoom in a little bit. And if it's a line that's parallel to it, let's just do it in green, it's going to go like this, right? So we're considering the x-axis to be a line, and then we've got this other line. I didn't draw it perfectly parallel. I can see that they don't look quite parallel, but I can't really change that easily. Anyway, so use your imagination. Pretend that they're exactly parallel. So they would never cross. So this green line is the one I want to get the equation of. It's going through the point -2, 3. How am I going to come up with an equation for that? Well, if it's parallel to the x-axis, we know that it's going to have the same slope as the x-axis, right? Because parallel lines have equal slopes. So the green line will have the same slope as the x-axis. What's the slope of the x-axis? Well, we might have already talked about this. I honestly don't remember, but let's just think it through. Anyway, let's pick a point on the x-axis. Let's start with the origin. It's the point 0, 0. Let's pick another point on the x-axis. Let's say that's the point 5, 0. They're both on the x-axis. Remember, slope is rise over run. So the slope between these two, it's got a rise going from the left point to the right point. It's not going up at all. It's got a rise of 0 and a run of 5, which is actually just a slope of 0. It doesn't matter what two points I picked. I could have picked any 2 points on the x-axis. They're always going to have y values of 0, aren't they? So the numerator will always be 0. The denominator can be any different thing, but 0 divided by anything will always be 0. So the slope of the x-axis is always 0, which means that the slope of the line that we want to get, the green one, I'll actually write it in green ink, so to speak, here, y equals mx plus b, we know that the slope that we want is going to be 0. And then, just like we've always done, I can find out what the y-intercept is by plugging x and y coordinates into the equation. Now I've used different colors for different days. I don't recall what colors I've used for my x and y coordinates, so I'm just going to go with blue and orange today. And so if I put my y coordinate in as 3, and I put my x coordinate in as -2, and then I'm going to solve this for b to get b isolated. 3 equals 0 times 2 is just 0. So it turns out that b is just equal to 3. That's my y-intercept. So I can go back and write my equation as y equals 0x plus 3. I think I've been using yellow for my slope up to now, so let's stick with that. But I could be wrong. So y equals 0x plus 3, but that might strike you as unnecessary to write 0x down, because why do I need to write down something that's not there? And you'd be absolutely right. A more simplified version of this same equation would just be y equals 3. That would be the equation of that green line. Let's wrap our heads around that for a second. Y equals 3, what does that mean? Really what it's telling us is that we can make up a whole bunch of points on this line, and it doesn't even matter what the x coordinates are. As long as we keep the y coordinate 3, then we will be able to find points on the line. You know, if you want to check that, let's pull some random numbers out of there. Let's say x was 10. Okay, x is 10, and y is always 3, so that might be a point up here. That's the point 10, 3. And maybe we think that x is -10. Okay, well that's down here. But y still has to be 3. Any point you pick on the line is going to have a y coordinate of 3, including the y-intercept. The y-intercept has to be 0, 3, right? Which leads us to another conclusion. I could have, if I understood this, if I understood that it has to be parallel to the x-axis, I could have skipped all this work I did and simply focused on this here, the 3, the y-coordinate in the point that it has to go through. Because then I know that all points have to go through that, and I could have just said y equals 3 without even doing any other work whatsoever. All right, example 2, find the equation of a line parallel to the y-axis through the point 5, -3. Okay, let's draw a graph. Y, x, 5, -3 would be somewhere around here. Okay, here's 5. That's not very tidy. 5, -3. If it's parallel to the y-axis, then it's going to be something like this. Let's move that over a bit so it's on the line. Okay, parallel to the y-axis. What if we want to use an equivalent idea for this one? Then what we could do is we could say, well, if it's parallel to the y-axis, it's going to have to be straight up and down. Every point on this line is going to have an x-coordinate of 5, right? Don't believe me? Well, let's check some out. Say we wanted to go up here to, let's say that's 8 on the y-axis. It still has to have a 5 for my x-coordinate. You know, if this was a 4 on the y-axis, well, it still has to have a 5 on the x-axis. You know, if I go down here to -8 on the y-axis, it's still got to have a 5 on the x-axis. So again, what's the important part here? The important part is that 5. the x always has to equal 5. Getting sloppy again. X equals 5. Now, there's some specific names for these types of lines. Anything that's parallel to the x-axis, if we go back to that, is called a horizontal line. And so we can even put a rule out there and say that all horizontal lines have a slope of 0. Because that's true. Any horizontal line is going to have a slope of 0. We just showed why that was true. So whether it's actually the x-axis or any line that's parallel to the x-axis, all horizontal lines are parallel to the x-axis, and they all have the same slope, and the x-axis is a slope of 0, so they must all have slopes of 0. Now, something funny is going on as far as the slope for a vertical line goes, which is what this one is. This is a vertical line. The y-axis is a vertical line. That's just a straight up and down one, which means that all lines that are parallel to the y-axis must be vertical lines as well. But what's the slope going to be for that? The slope for a horizontal line is 0. We know that perpendicular lines have negative reciprocal slopes. Let's use that, because horizontal lines and vertical lines are perpendicular to each other, aren't they? Think about that. Horizontal lines and vertical lines are perpendicular to each other. So if I know that the slope for a horizontal line is 0, then the slope for a vertical line must be the negative reciprocal of that. So if I take 0 and change the sign, and then flip it upside down. So again, how do I flip 0 upside down? Well, think of it as a fraction. So I could think of it as 0 over 1. Let's not put the negative sign there yet. So there's my slope of 0. If I want a perpendicular slope, this is where I then take the fraction and flip it upside down and change the sign. This would be the slope for a vertical line here. But what is that? What does it mean to divide something by 0? You might want to just pause this video for a second and check it out for yourself. Obviously, I can't make you, so I'm going to keep talking, but you might want to check that out. What do you get when you divide something by 0? Well, what you get is your calculator will tell you that it's an error. So if you divide any number, including -1, by 0, your calculator should tell you that that is an error. And the reason is you can't divide by 0. You probably learned this a long time ago, and you may have forgotten it, I don't know, but you can't divide by 0. So what does that say about the slope of a vertical line? That means that we call slope of vertical lines undefined. Since we can't do it, there's no definition for it. There's no definition for dividing by 0, therefore that slope is undefined. So this is something you just need to memorize. You need to memorize that all horizontal lines will have slopes of 0, and all vertical lines will have slopes that are undefined. I guess that's good enough. All right. What else can we say about that? I'm not sure. Let's go on to the next example. Find the equation of a line that's perpendicular to this line and passes through this point. All right, so from this, all we care about is the slope. If it was parallel to this line, we would just take that slope and that would be our slope we want. But since it's perpendicular, again, here's the slope of this line, but here is a perpendicular slope. Again, that little symbol means perpendicular. I'm going to flip the fraction upside down and change the sign. So I'd rewrite that maybe as just -3. So the slope of the line that I want is -3. Let's go back to y equals mx plus b and plug in the slope. Now I've got the slope of the line I want, but I don't know what the b value is. That's where I can plug in -2 and 5. So 5 goes in for y, -2 goes in for x, and we will solve for b. So we get 5 equals +6. -2 times -3 is +6. I will bring that 6 to the other side by subtracting it. I'll get -1. That's my b value. My answer then becomes -3x minus 1 when I put all the pieces together. And there is my solution for that one.